everyone, and happy Thursday. Today we are going to get introduced into logarithm functions. And to get into this, we're going to start out with what we know already about how to find the inverse of an equation. Now, we've done this before in Algebra 2. And when we want to find an inverse of an equation, what we're doing is we switch the x and the y. Whoops, that looks like they. Sorry. Switch the x and the y, and then solve for y. That's how we find the inverse. So just as an example to get you guys in the idea and to refresh your memory of an example of how we did that this semester, let's say we have, let's say we've got y equals x squared. Y equals x squared. Just made that up off the top of my head. I know, super basic. Anyways, if we want to find the inverse, we are going to switch x and y. So that means we have x equals y squared. And then we want to solve for y. Meaning we want to get y all by itself. Well, to get y all by itself, what do we need to do? What's bugging the y right now? This squared. How do we undo a square? We take the square root. Exactly right. So we have this x equals y squared, and we're going to be taking the square root on both sides. So that means we end up with the square root of x equals y. So these two equations are inverses of each other. Alright? That's how we find an inverse. But what about if we had something that looked like this? Y equals 2 to the x. Alright. Now, you're right that to find an inverse, we have to switch the x and the y and then solve for y. I want to show you something really quick that's going to introduce us into logarithms. So, if we switch x and y, then that means what we have is now x equals 2 to the y. Alright, now how do we solve for y? How do we get y out of that exponent, out of the power? This is where the log comes in, alright? Because we can't take the square root or the y root on both sides, because there's no such thing as that. We have to use a new type of function, which is called a logarithm, in order to find our inverse here. Alright, so here's where we get into logs. All right, I'm going to give myself a little bit more space. So we know if we have an exponential equation that looks like, okay, so I'm going to say exponential, and let's just say we're just going to use variables for right now. The basic outline of an exponential function is some number to a power equal to your answer, right? That's a typical exponential equation. That's your base, there's your power, and there's your answer to this exponential function. If we want to look at a logarithm, the basic outline of a logarithm is going to be, I'm going to use a cursive L, and that way it doesn't look like the number 1. So log, and then B is going to go down here as a subscript. That's the base of your log. All right, then we've got y equals x. All right, so these equations are inverses. All right, these equations are inverses to each other. So if we're given an exponential function, an exponential equation, we can shift and move these variables and numbers around to make it a logarithmic function or a logarithmic equation. Now, just like there's 3 parts here to an exponential equation, your base, your exponent, and your answer, there's also 3 parts to a logarithmic equation. Okay, that b, the y, and the x, they have special names. So, just like in your exponential equation, the base of your exponential function is also called the base of your logarithm. Alright, so both of these are bases. Alright. This x, this is our power. Alright, and your power ends up being your answer in the logarithm. And then the name for this y is our argument. And the way that I think about it is you are arguing your case. You're showing that the base to this power is going to equal whatever number this is. So it's your argument. It's what you're trying to prove. All right? So those are the 3 parts to a logarithm. Now, all that we're going to focus on in this lesson right now is going to be converting exponentials to logarithms, and then the other way around, converting logs to exponents. All right? Now, I'm going to keep this at the top of the page for us to kind of look at as we take a look at some examples. All right? So, the first thing that we're going to do is convert these exponents to logs. Alright, I'm going to put a couple here. Alright, so here's our examples for converting exponents to logs. These are all in the exponential form, and we want to put them in this logarithm form. Alright, so if we're putting it in log form, I know that we're going to start out with log, and then I want to know what is the base of my exponent? Well, the base is 10, so that 10 is going to become the base of my log. Alright, then instead of the 2 coming next, my argument goes with the log. So my argument is going to be 100. So log base 10 of 100 equals my power 2. Alright, our next example, again, we're going to start out with log. What's the base of our exponent? 4. The base of our exponent is the base of our log. After the base comes the argument. What is our argument? The 64. And it's going to be equal to our power. Alright, how about the next one? Start with your log. What's your base? Yeah, it's a fraction. It's okay that it's a fraction. You can either write it as a fraction, 1/2, or you could write it as a decimal, 0.5. Alright, what comes after your base? The argument is 8, and it's equal to our power, -3. And then for this last one, log of, what's our base? 125. What's our argument? 5. And it's equal to our power, 1/3. Alright, so that's converting exponents to logs. The other thing we're going to look at is going the other way around. If we're given the log, can we convert it into the exponential function? Alright, so I'm going to move those up here, give myself some more space. And we are going to convert these logs into exponents. Alright, here's our examples. Log, there we go. That way it doesn't look like the number line. Log base 5 Ooh, that number's wrong. Sorry, I'm going to change that. Log to the 1/8, that's what it should be. Alright, so these are in log form and we want to put them in exponential form. So to start this out, we want to know what's the base of our log, because the base of our log is going to be the base of our exponent, and our base is 5. All right. Now, what's our power? Our answer to our logarithm is going to be the power of our exponent. So, squared. And 5 squared is 25. There's our argument. All right, let's try the next one. Our base is what? 1/8. What should our power be? -2. And then it is equal to 64. And then our last one, our base is 100. Our power is 1/2. And that is equal to 10. Alright, so that's what we're focusing on today. Once you've got a handle on these examples from the notes, go ahead and take a look at the assignment that is on Google Classroom. I'll see you guys next time.